So let's talk about the different parts of the brain and what they do. Parts of the brain are functionalized for different purposes. They do different things, which is why damage for different parts of the brain has different effects. It's why then you look at an fMRI scan or PET scan or something that records neural activity, you could figure out based on the location or the activity what's going on. So the first thing to realize is I'm talking about the brain, but at more precise and more inclusive if I talk about the brain and part of the spinal cord. So you don't need your brain for everything. There's certain activities we do that can happen without a brain, like sucking in newborns or pulling your limb back to withdraw from pain or vomiting. But for everything else that we talk about in this course, we'll really be talking about the brain. So some of the structures of the brain that are highly relevant or are called subcortical, which means they are below the cortex, which means they are in the center of the brain. This includes part of the brain like the medulla, which controls certain automatic functions like your heart rate, your blood pressure, slowing, and so on. It includes the cerebellum, which is involved in body balance and musical coordination. It contains about 13 billion neurons. So this isn't small potatoes. The hypothalamus, which is involved in finding and sex and thirst and different appetites. We're going to talk about emotions or visceral desires. We'll return to those parts of the brain, but for the aspect of psychology that are distinctive for that make as human, we are mostly focused on the outer lie, the cerebral cortex. So the cerebral cortex is all capable up. If you were to take a brain, pull out the cortex and straighten it out like you're removing a rock. You go from the trunk of your car and you have to straighten it out. It's about 2 feet square. So it's a lot of crumpling to get it in. It's about 3 millimeters thick. This is the action is. This is where, at least for the things I'm interested in, this is where it takes place. Is the reasoning and language and complex perception comes from. Fish don't have any cerebral cortex, reptiles and birds have a little bit, but primates, including humans, have a lot. Then you look at the cortex, you will see it has two halves. It has a left half and a right half. For each of these halves, then you look at it, you can demarcate the brain, the cortex into different lobes. This going from your forehead and swooping to the back. You have the frontal lobe conventionally enough on the front, the parietal lobe, the occipital lobe, and the temporal lobe. Each of these lobes, there's different things which we'll talk about in a bit. Another things about the cortex thoughts which is super interesting is that it includes maps. What I mean by this is it includes topographical maps. The two things that are close together in the brain are similarly close together in the body. So there is a motor area there. If you were to shock part of the brain, part of the body would twitch accordingly. Just like you expect the middle finger is close to the thumb, which is close to elbow. If it's close in the real world and your body is close to the brain and there is a primary somatory area which is the sense organs. There, if you have somebody in the operating table and you shocked people, they would experience things. They might experience a sound or a flash of light or a tap. In fact, in the occipital lobe you have a map for vision, and in the temporal lobe you have a map for sound. What's real cool is I said that the map is topographical, but the size of the brain is don't correspond to the size of the actual body areas, but rather to the extent to which this motor or sensory function. So artists have drawn pictures of people if the body was proportioned to the extent that the brain was. You see the trunk of the body is relatively small, but the hands are enormous and the face is enormous because there's a whole lot of ascension. This is much more ascension going on in your hand than in your whole back, even though the back is physical part. So part of the cortex in these projection areas, but less than a quarter of the cortex contains projection areas. As I said, the rest is involved with the cool stuff. with language, with reasoning, with moral thoughts, and so. Then the question comes in: how do we know this? How do we know what part of the brain do what part of the brain are involved, and why? There's different answer. So one answer in we can scan the brain. We can use MRI, which is a high frequency magnetic field to look at the activity of the brain, what part are activity, then people do different things. We can also look at so-called natural experiments, then people have tumors or strokes or motorcycle accidents. It damage part of your brain, and we can ask the question: what damage to which parts of the brain correspond to manage to which functions? Through these different matters, we learn about these different parts of the brain and what they do. We could talk about some certain specific things that can go wrong due to brain damage or stroke or trauma. So, for instance, this apraxia. Apraxia is problems of actions. So you unable to do an action like waving goodbye or waking up before you or can bring some food to your mouth. You are not paralyzed. You can make the movements if you have to, but you can't coordinate these basic movements into complex actions. This agnosia is a discourse of respiration, and they are not like you can't see, but you can't recognize. Some is called physic blindness. People of various forms of agnosia can describe a picture in terms of its part, but can't recognize the objects that are being depicted. That's forms of visual agnosia. There's also a specific prosopagnosia. There you can recognize faces. Oliver Sacks wrote a wonderful book many years ago called The Man Who Mistook His Wife for a Hat. This was a series of profiles of people who had surprise neurological disorders, and the title case of the book was A Man Who Actually Had Such an Inhibition to Recognize Faces. He couldn't distinguish his wife's face from that of a hat. Other forms of prosopagnosia which some people suffer from, and to be honest, I got a little bit of some terrible faces, is that you could recognize face as face, but you can't recognize those face they are, and it's very hard for you to recognize people. These problems of sensory you get disorders that block out one part of the world. You might have damaged part of your brain that would block out the left side of the world. It's just the sort of physical thing. Then you ask somebody with such a disorder to draw clock, for instance, they plot all the numbers from 1 to 20 on the right side of the clock. It's as if they don't think of the left side of the world again. So maybe it's not even a sensory problem, but an intentional problem. This aphasia, which refers to disorders of language. Some forms of aphasia are expensive, like a broken aphasia, there you can really speak. A famous case of somebody who can only use the word 10 would say 10, 10, 10, while could say anything else. Oh, then there's something that called receptive aphasia, there you can speak, although what you say doesn't make much sense, but also you have a terrible time understanding other people. Then there's all sorts of other disorders. This the disorder which we talk about with regard to Finis gauge and various forms of it. The damage to your brain is detectable that this is to Finis gauge, but there are other cases that it's much more clear. Cause you to lose your moral sense, your sense of right and wrong, your ability to control yourself, to restrain yourself, perhaps your consistency. Now we are going to talk about all these things through the course, but the moral here is that there's some localization on function. There's some sense in which correspond to different brain areas. B. Again, this is an argument against dualism. You can see that in the any who argued that the mind isn't the brain would be hard-pressed to explain why damage to the brain seems to affect some very intimate and